Welcome. So today's video is going to be on mass and moles. So in chemistry, we use atomic mass units to describe the mass of an atom. So one atomic mass unit is 1/12 the mass of carbon, of one atom of carbon-12. So if we want to find the mass of an atom of another element, would be relative to 1/12 the mass of carbon-12. So this is called the relative atomic mass. The relative atomic mass is the average mass of an atom of an element compared to 1/12 the mass of carbon-12. The reason why they say average is because relative atomic mass takes into consideration isotopes as well. So this doesn't just apply to atoms, but it also applies to compounds as well. So the relative molecular mass is the average mass of a molecule of a compound compared to one atomic mass unit, which is 1/12 the mass of carbon-12. And relative formula mass is the average mass of one formula unit of a ionic compound compared to one AMU. So in the previous video, we determined that 12 grams of carbon contains 6.02 times 10 to the 23rd atoms. So if this is the case, then I can also say that for an element like aluminum, which has a relative atomic mass of 27, then 27 grams of aluminum contains the same amount of atoms. But why is this? So let's take a look at carbon. Carbon has a relative atomic mass of 12. So if carbon has a relative atomic mass of 12, and 12 grams of carbon contains 1 mole of substance, then we can say that the relative atomic mass, relative formula mass, or relative molecular mass is equal to the mass of that given atom or compound, which will contain 1 mole of particles. So 12 grams of carbon-12 will contain 1 mole. 27 grams of aluminum will also contain 1 mole. But what about a compound like sodium chloride? Let's try and figure this out. So sodium chloride is a ionic compound. So we'll be finding the relative formula mass first. So sodium has a relative atomic mass of 23, and there's 1 atom of sodium, so that's 23 times 1. And chlorine has a relative atomic mass of 35.5, and there's 1 atom of chlorine. We'd add these two together to get the relative formula mass, which is equal to 58.5. Note that relative formula mass and relative atomic mass do not have units. But we can now say that 58.5 grams of sodium chloride will contain 1 mole of particles. What if we were told that we have only 40 grams of sodium chloride? How would we be able to determine how many particles are present, or how many moles are present in the sodium chloride? So what we'd say is that if 58.5 grams of sodium chloride contains 1 mole, and 40 grams of sodium chloride contains an unknown value, let's call it X moles, what we can do is that we can put this into an equation by kind of cross multiplying it like this. So this is going to be 58.5 grams times X mole is equal to 40 grams times 1 mole. So in order to find X mole, we're trying to get X by itself. This is just some algebra. So we'd be moving over the 58.5 to the right. So we'd be dividing, since we're multiplying right here. So going to be 40 G mole over 58.5 grams. So we can cross out the G right here, so that we'd be getting moles. And if we put this into our calculator, we'd get 0.68376. But whenever we are dealing with quantities in science, you have to remember that we should be putting it in scientific notation. So this is going to be 6.83 times 10 to the negative 1 mole. So that's how we'd find how many moles are present in the sodium chloride. So with that being said, this should be the end of today's video. I will be making another video covering moles and gases very soon. So please do like and subscribe. Turn on your notifications if you're interested in that video, so that when it does come up, you can see it first. So thank you for watching, and bye bye.